So this is the question in which we have given a figure with two resistor, I think so, and of 20 ohm one. We have to find the other, and an ammeter of 0.4 ampere. Basically, ammeter measures the current, so we have given with the current. Voltmeter measure the potential difference, so we are given with the potential difference. Now let us start the question. What was the, according to the figure we have asked, the total resistance? Okay, so V is equal to I into R. Okay, according to Ohm's law. Okay, so you are given with V already. Okay, so you are given with V already, and I was also given 0.4, which was measured by the ammeter, into the resistance. Now this will is the total resistance. You will find the importance in second part. 0.4 is equal to your resistance, that is total. I am specifying total word. 10 is your resistance, total resistance. Okay, now we have completed the A part. Now B part, according to figure, this figure has a parallel combination, that is 1 by R is equal to 1 by Rp is equal to 1 by R plus 1 by 20. Okay, so this, it has a part, so we can write like this. So 20, we could take the LCM as 20R and 20 plus R. Okay, leave it like this, it will give further information about it. So we have total resistance as 10. We have to find the value of R. Now we have find the total resistance. Okay, now substituting the value, cross multiplying, substitute, you have got the value of the capital R, which is 20 ohm. Okay, very simple. Now we go to the third part. What is the current flowing through it? So you know, according, I have also written here also, V is equal to I, a very important Ohm's law. So you are given the resistance, you have found the resistance as 20, to I into 20, and you have, it is a constant given that V is 4, and voltmeter actually do not change. For example, if the battery has the voltmeter of 15, then it does not changes. 15 volt battery, it changes only when it is used, but here a key is not specified in the figure. So 0.2 ampere is your current. So you can take the screenshot if you like. Let us proceed to the next question. A particular resistant wire has a resistance 3.0 ohm per meter, means 1 meter contains 3 ohm. So here it is written that each means we have 3 resistance. One is of 1.5 into 3 means 4.5. So 4.5, 4.5, 4.5. Okay. B. The potential difference of the battery gives a current of 2.0 in each length when it is connected in parallel. So we will draw parallel and each will give how much? 2.0. Now the third part says that the resistance of 5 meter length of a wire of the same material but with twice the area of cross section. In this you have to remember the formula, P is equal to rho is equal to RL by A. So inversely proportional, that I will do in the question. Let us start. Okay, now that we have how much? 3. So 1 meter consists of 3 ohm. Okay, so 1.5 meter is equal to 4.5 ohm. Okay. Now I am drawing the diagram. These three are in parallel. Okay. Now 4.5 ohm, 4.5 ohm, and 4.5 ohm. Okay. Let us add it total. 1 by 4.5 plus 1 by 4.5 plus 1 by 4.5. Can we write it 3 into 1 by 4.5? That it 1.5. So 1 by RT or R total 1.5. So RT is equal to, reciprocating on both the side, 1.5 ohm. Understood? Now, a second part says that to find out the V, they have given the I as 2.0 ampere. We have find the RT, that is total resistance, at 1.5. Okay. Ohm. So gives a current in each of the length which is connected in parallel. So each of the length means one consists of how much? 4.5. So 1.5 into 3, because each contains 4.5 volts. 1 point is equal to 4.5 ohms. Okay. So V is equal to IR, Ohm's law, to 4.5. We have multiplied them together. We got 9 volt. Okay. Now let us come to the third part. It says that the resistance of 5. Now we have the 5 meter length of a wire and twice the area of the cross section. Now let us come to the procedure. First, let us go to this relation. Okay, 1 meter consists of how much? 3 ohms. So 5 meter would consist of 15 ohms. Let us write here. This is our third C part. So this was B part. 5 meter consists of 15 ohm. Okay, 15 ohm. And they have said that it is halved, means we have a formula, rho is equal to RLIA. Actually, rho does not depend on length, but we, due to this numerical, we have assuming that this is inversely proportional to this 1 by area. So when it is doubled, due to the inverse proportionality, it is halved. Okay, so we will half 1.5, half of 1.5, 15. I have written 15. So you will get 7.5 ohm as your final answer. I repeat it again. 1 meter consists of 3 ohms. 1.5 meter would consist how much ohm? 4.5 ohm. Each consists of 4.5. 1, 2, 3. On solving, I got total resistance as 1.5 ohm. Now, here in the second part, it is given that it gives a current as 2 ampere, and in each of the length, means each of the length 1.5 meter, one length consists of 1.5 meter and gives how much current? 4.5. That's why I have shown again multiplication. I have done IR. Then 5 meter, I mentioned that if 1 meter consists of 3 ohm, 5 meter will consist of 15 ohm. But it is written that it is doubled. So, but according to the inverse proportionality, which is doubled becomes half. A cell supplies a current of 1.2 ampere. Okay, so I is given 1.2 ampere through two resistors, each of 2 ohm. They are in parallel, and same is connected in series and supplies a current of 0.4 ampere. Let us do the solution. As we all know that EMF is equal to capital V, that is terminal potential, and voltage drop. Okay. So it can be written as IR plus I small r. Okay. We could take the I as common, but we have given I as 1.2. Okay. We have taken I as common and would write as like this. So I think we have given some information about capital R. Yeah, it is 2. 1.2 R, that is, and the we this is given. Okay, so we are given as 2 plus. Okay, there is a small r depending on voltage drop or the internal resistance. Okay, and this is R, this capital R is given to us, and current is also given to us. We have to find the EMF, so we have made it as a question number 1. Okay, now let us go to the second part of the question. What it says, that when these resistors are connected in series. Okay, no problem, it is connected in series. So E is equal to V. So we are E is equal to K. Now we are going to second equation. Now what it happened, that it is connected in series. Okay. So actually these are connected in series. Both 2 ohm resistors were connected in series. So 1 by RT is equal to 1 by 2 plus 1 by 2. 1 by RT is equal to 2 into 1 by 2, which is 1. So here you can replace it as, because since they both are connected in parallel, so 1 plus R. Okay. Now say V is equal to again IR plus IR. E is equal to IV, take common, R plus R. Okay, so what we have given this time as I, we are given at 0.4 ampere. Okay, and what is this time we have given as capital I? Since they are connected in series, so no problem, we can simply add 2 plus 2, that is 4. So 4 plus R. Okay, now since they both are equal to E, we can simply equate it, equating 0.4 plus R. Okay, 1.2 plus 1.2 R is equal to 1.6 plus 0.4 R. Okay, and we start substituting. 0.8 R is equal to 0.4. R is equal to 0.4 by 0.8. Okay, so we get as 1 by 2. Okay, or 0.5 ohm. Okay, putting it on the equation second. Actually I have not mentioned here is the equation second. 0.4 into 4 plus 0.5 is this will become as 4.5, and 4.5 into 4 will become 0.8 volt. Okay,